eigenvectors. I just made a video about eigenvalues, and since they're really connected, I'm just going to do a video about eigenvectors now. And so let's just start with the definition. And I already covered this like in the eigenvalue video, but I'm just going to repeat it. Eigenvectors are vectors that point in the same direction after acted on by a matrix, and they're scaled by the eigenvalue. Like for example, if they stay in their same direction, that makes them an eigenvector. And let's say they double in length, when the matrix acts on them, the eigenvalue would be 2 for that eigenvector. That's just an example. So this is the formula if you want to find an eigenvector. The set of all eigenvectors of a matrix is equal to the null space of A, which is the matrix that you're going to find the eigenvector of, minus I, which is the identity matrix, times lambda. Lambda is the eigenvalue for that specific eigenvector. And I think that's all there is, so let's just do one example. You'd find the set of all eigenvectors for one eigenvalue of the matrix 1, 2, 1, 0. So we need to find just one eigenvalue. So there's going to be 2 eigenvalues, and just choose one of them. And for that one, find the set of all eigenvectors. So let's just get started. First you have to find the eigenvalue. So you use determinant of A minus I lambda equals 0. Where A is 1, 2, 1, 0, that's the matrix we want to find the eigenvector of, and I is just, it's 2 by 2, so it's just going to be 1, 0, 0, 1 for 2 by 2, the identity matrix, and lambda is what we're solving for. So let's just find this part first. A minus I lambda. A is 1, 2, 1, 0. Minus I. So I would be 1, 0, 0, 1. So it would be a 1 here and a 1 here. And since you're multiplying it by lambda, you just multiply lambda by each element. The 0 stays 0. This would turn into lambda. And this would turn into lambda. Because 1 times lambda is lambda. And to subtract these two, you just subtract every single element. So 1 minus 1 minus lambda, that's going to be our first element. Zero minus lambda, that's just negative lambda. And then 1 minus 0 is 1. And 2 minus 0 is 2. Okay, so now we have to set the determinant of this. Just gonna write that in. The determinant of this has to equal 0. And to find the determinant of a 2 by 2 matrix, you just do 1 minus lambda times negative lambda minus 2 times 1. And that must be equal to 0. So you get negative lambda times 1 minus lambda minus 2 times 1, which is so minus 2, equals 0. And then we just distribute this. It's equal to negative lambda plus the negatives cancel out. Lambda squared minus 2 equals 0. So now we just solve this quadratic. Let's factor it. So we have negative lambda and minus 2. What two numbers multiply, you get negative 2, and if you add them, you get negative 1. It's negative 2 and positive 1. So lambda minus 2 times lambda plus 1. And that must equal 0. So now we do get the two values for lambda, and we're going to choose one of them to find the eigenvectors for. So it could be 2, and the other value is -1. And I'm just going to choose this one. You could do 2 as well, as an exercise maybe. I'm not sure. We're going to choose -1 to find the eigenvector vector for. And so how we're going to find eigenvectors with this formula. So the set of all eigenvectors is going to be the null space of A minus I lambda. And we've already found A minus I lambda to find the eigenvalue, and that is this. 1 minus lambda to 1 negative lambda. Now we just plug in the lambda we want, which is -1. So we want to find the null space of 1 minus lambda, 1 minus -1. Just going to put this as lambda. 1 minus -1, that's 2. Then 2. And then 1. And then 1 -1 is 1. So 2, 2, 1, 1, the null space of this. So null space is all the vectors that if the matrix acts on them, you get 0. The 0 vector, which is just 0, 0 for 2 dimensions. And so we have to set up the vector that we're trying to find as write out the components as two scalars, vector v1 and v2. That's the vector we're trying to find. And then we have the matrix 2, 2, 1, 1 acting on this, and this should get 0, 0. The 0 vector. So we're just gonna write it out. So v1 would be times 2, and then times 1, you add them together. So you get 2v1 plus v1, 1 times v1, it's just v1. And then now we do it for v2, plus 2 times v2 plus v2. Both the column vectors for this matrix are identical, so we just get the same for each vector. Sorry, v2. And this should equal 0. So now we can just combine like terms, and it would be 3v1 plus 3v2, and then you could just factor out the 3 and divide by 3, so I'm just going to write it simplified. v1 plus v2 equals 0. Or v1 equals negative v2. So, and we want to find all the set of all vectors that obey this, that like the top component equals the negative bottom component, or vice versa, v2 equals negative v1. And so we can write this as any vector. All the vectors that obey this are any vector where it's some c, which is just a scalar. It's like a scalar. Any scalar times 1, -1. Or this could be -1, 1. Either way. Any scalar times this vector would give us a vector that obeys this. And this is the same thing. We can write this as a span of a vector. The span it's just how many different vectors you can make by multiplying something by a scalar. The span of the vector 1, -1. So the span of this vector is every single vector that obeys this, and that means that's every single vector that's the eigenvector. That's our answer. Thank you for watching. Bye.